degrees, in part due to the expectation that La Nina will fade over the year. Now, the global temperature, although it is generally increasing due to human-induced climate change, there is variation from year to year. And there's the same kind of drivers that are driving that variation that drives the variation in rainfall interannually as well. If we could just move forward a slide, please. The clicker's not working. Okay, thank you very much. So there are a number of large-scale drivers of variability in the climate system. They include things like soil moisture, volcanic eruptions, dynamics in the very upper atmosphere, the stratosphere, and then, as I've highlighted here, sea surface temperatures or ocean temperatures as well. And they are slow variations in sea surface temperatures that drive phenomena that we may be aware of, such as the El Nino Southern Oscillation, or ENSO, and the Indian Ocean Dipole, or the IOD. Next slide, please. Okay, so let's start by looking at ENSO. We have to focus on the tropical Pacific. And we can see from last month that the temperature anomalies, that's the difference from average conditions, is slightly below, which is the general pattern that we expect from a La Nina. And the official ENSO status is currently still a La Nina. Next slide, please. That's great. Thank you. But if we now have a look at the time evolution of those surface temperatures in the Pacific, we can see that they are gradually warming up as we've moved from the peak of La Nina in November until now, showing that La Nina is indeed fading. Next slide, please. But we really have to look at global seasonal prediction models to actually see what's coming up ahead. And with a great degree of confidence, those dynamical models from global producing centers like ECMWF, Météo France, UK Met Office are showing that we should expect a transition to ENSO neutral during the March, April, May season. Next slide, please. Okay, thank you. So then we have to ask the question, how important is the state of ENSO for the March, April, May season? And we can look at that using what we call these correlation maps. They're essentially telling us whether the state of ENSO is connected to rainfall in East Africa. And what we can see from the figure on the left-hand side, due to the lack of shading, is that there is no real connection. Next slide, please. Okay, so then we can move to the Indian Ocean Dipole, which is a gradient in sea surface temperatures across the Indian Ocean. In September and October, it was negative, and that was driving the drier conditions in the short rains period. It's now moved to neutral. Next slide, please. Again, we can look at global prediction models, and we find that there's an expectation that the IOD will remain in a neutral phase through March to May. Next slide, please. Again, what we can do is we can look to see whether the IOD has an effect on rainfall variability in March to May, and unfortunately, it doesn't. And the fact that ENSO and the IOD don't have this connection with rainfall variability in the March, April, May period is why it is so difficult to provide predictions for that season. Next slide, please. Okay, so the question then is, what can we do if ENSO and IOD can't help us with prediction of conditions for the season ahead? So we have to explore new or alternative or experimental drivers. Next slide, please. Okay, so the first of these is looking towards the Western North Pacific, or the Western Vertical Gradient, which was a method developed in the University of California, Santa Barbara in 2018. And this methodology is indicating a potential new teleconnection that can predict dry seasons in March, April, May. And the reason I'm showing this as well is because this is a methodology that has been integrated into the ICPAC forecast for this season. It is a new methodology. And using this methodology alone, there is a prediction of a 50% chance of drier conditions for the season ahead. Next slide, please. We may also have to look at drivers of variability on timescales shorter than seasonal, so monthly timescales, sub-seasonal. One of the most important drivers on sub-seasonal timescales is the Madden-Julian oscillation, this eastwards moving pattern of both enhanced and suppressed convective rainfall. The problem with the MJO is that there is limited predictability on seasonal timescales, and so we can only often say what's happening with some degree of confidence out to about 2 weeks. And for that reason, it's incredibly important that we all stay up to date with the latest forecasts from the National Met Services and from ICPAC as well, because it will fold in the latest information about these subseasonal drivers. So the ICPAC March, April, May forecast today is an excellent starting point, but please do keep up to date with the latest forecast as well. Next slide, please. Thank you. Okay, so in summary, 2022 was a record year for many in terms of temperatures, despite the fact that there was this La Nina, which was imprinting a cold influence on the atmosphere. A warmer 2023 is expected in terms of a global average. And temperatures are so important. If we have a dry season, we need to make sure that moisture stays in the soil. So temperatures has a huge effect. La Nina conditions are officially still present, but they are fading. And dynamical models are predicting that there will be a transition to ENSO neutral. But there is a lack of connection between ENSO and rainfall in March, April, May. The IOD is currently neutral and expected to remain neutral. But again, there's a lack of connection between the IOD and rainfall variability in March, April, and May. The Western vertical gradient in the Western North Pacific methodology indicates slightly enhanced chances of a drier season. And that methodology has been integrated into the ICPAC forecast. And then finally, we must acknowledge that there are drivers on subseasonal timescales demonstrating the real importance of having the latest information from the forecasters. So please stay up to date. Next slide, please. I think I've gone over time. So thank you very much indeed for bearing with me. And I shall pass on to the next speaker.
Thank you very much, Dr. Lins. Please give him one more answer. Yeah, upload. Thank you. Thank you very much. Next presenter, please. Kindly display the presentation in the meantime. Dr. Zaudu?
Yes.
Definitely, you don't need introduction. So yes. Please, the floor is yours. Go ahead, and you have 8 minutes.
Thank you. Thank you. Waiting for the slide to come up.
In the meantime, please keep your questions, and there will be sometimes like 8-10 minutes or so at the end of all the presentations, and then you'll pose your question at the time. Thank you. Dr. Zaudu.
Thank you very much. So I'm presenting the state of climates and the global climate forecast from the NOAA Climate Prediction Center. So this guidance was issued in mid-February. Next slide, please. Yeah, just to show the climate has been dominated by cooler sea surface temperature anomalies over the equatorial Pacific, and that has been affecting the climate of the Greater Horn of Africa. If we look back, all the blue show the sea surface temperature for Nino 3 region, and the bottom time series show the same in terms from 1982 to the present. So what we see currently at present is that cooler temperature occurring for the past 3 years. Similar it did this year. So during 1998, the same thing happened. There had been a triple dip in La Nina event, and which led to a cooler sea surface temperature after the end of that episode. And what happened? 1998 was wet, 99 was dry, 2000 was dry, 2001 was dry. So currently, since 2020 was wet for March, April, May. Then 21 was very dry, as we know. 2022 was also very dry, as we know, and it's continuing to 2023. I think we can skip the next slide, but it shows what the current state of environment is in terms of sea surface temperature over the Indian Ocean and the Pacific Ocean. So these are the main drivers of climate, whether there is a statistical relationship with El Nino or ENSO or IOD. The sea surface temperature, a slowly varying driver, is the results in the climate that we know. So last week, the SST was extremely, it's weakening over the Pacific and warming up over the Western Indian Ocean. So there is general, the La Nina condition is continuing. We can go to the next slide. It's continuing while weakening. And this is the CPC, the Climate Prediction Center of NOAA, and RRI produced in early February. What it shows is there is a 94% chance of the March, April, May being a neutral year, which Dr. Stefan has shown us. Next slide, please. So what I'm presenting now is what the model provides us. So the model includes all the sea surface temperature forcing, including the western V gradient in the northern Pacific. So this is the temperature forecast for March to May. And what it shows is there is generally an increased trend, the increasing trend continuing across much of Africa. There is a higher enhanced probability, Eastern Sudan, Chad, and the Democratic Congo Republic. There is a cooler chance, a higher chance for cooler than average temperature in around Zambia and neighboring Zimbabwe. In terms of precipitation, the next one, please. This is the model output from the North American multi-model. It's a combination of 6 models from the US and Canada. So the March to May 2013 is likely to be dry over Eastern Africa and wet over southwestern Africa. The if we go next, the below average over Eastern Africa is likely to dominate during March, April. The next slide, please. So this is the monthly distribution of the forecast on monthly basis. So the below average rainfall is most likely to dominate with higher probability in March and April over Eastern Africa, and wetter conditions in over the south. The gray shaded area is areas that do not normally have rainfall. So those are, they don't have skill and they are excluded. So March and April, especially April, is the peak season, and there is higher probability of getting drier condition in April, which definitely likely to affect the rainfall. Next slide, please. In conclusion, and so neutral conditions are expected to begin within the next couple of months. We have seen that the 3-4 region is cooling down, breaking up. The Indian Ocean dipole also is largely neutral, although there is some warming up coming over the Western Indian Ocean and cooling in the east. Generally, above average rainfall over parts of Southern Africa is expected. The model also indicates increased probability for below average rainfall over parts of Equatorial Africa. Details will be from Dr. Hussein. Thank you very much.
Thank you very much, Dr. Zaudu. You saved us a minute and a half or so. Dr. Hussein, the floor is yours. Kindly go to the podium so that the camera team can also do their work, and for the purpose of online viewers and participants as well. Thank you.
Hi, good morning, everyone. My name is Hussein from ICPAC. I will be presenting the downscaled regional climate outlook for the Greater Horn of Africa. And most of you have seen this yesterday. My colleague Eunice presented this for generating the advisories for the different sectors. So I'll be starting my presentation by showing the spatial distribution of March to May rainfall season. And when you look at the March to May rainfall season, the progression starts from the south. From the south, and it moves to the north. So during March, the rainfall is concentrated over the southern part of the region, mostly over Tanzania, parts of Rwanda and Burundi. And April is the peak of the rainfall season, and the rainfall mostly covers the southern and as well as the equatorial parts of the region. In May, which is the start of the summer rainfall season, the rainfall band is mostly concentrated over the northern part of the region. And when you look at the contribution of March to May rainfall season to the annual total, you can see the season is very, very important over the southern and as well as the equatorial parts of the region, particularly over parts of Somalia, Kenya, and southern Ethiopia. The season contributes to up to 60% to the annual total rainfall. This means that this particular season is very, very critical for that part of the region. And since most of the seasonal products are presented in terms of probabilities, it's also good to understand what is normal, what is above, and what is below. So this map shows the thresholds for above and below categories. And these categories varies from place to place. So if you look at parts of Tanzania, for example, when the rainfall is less than 600 millimeter, it is classified as below average rainfall. If it is exceeding 700 millimeter, it's categorized as above normal rainfall. But if you look at parts of the Somalia and also parts of South Sudan, Southern Ethiopia, and Kenya, that threshold is very low. So the normal category for that region is from 170 up to 195. If it is less than 170, it is categorized as below. And if it is exceeding 195, it is categorized as above normal rainfall. And our consolidated objective forecast is produced using different models and different techniques. So the map on the left, you can see the multimodal average from the different techniques that we use in ICPAC. And the final consolidated forecast is the average of all those techniques. So on the right, you can see the consolidated forecast with probabilities for below and above, and also normal categories represented in the different corners of this map. So when you look at the final outlook, we are expecting below average rainfall over most parts of the region, mostly over the Eastern Horn region, Southern Ethiopia, most of Somalia, and Eastern Kenya region, as well as parts of the Western South Sudan, and also Western parts of and Uganda, and also parts of Tanzania. Wetter than usual rainfalls are expected over parts of central and southern Tanzania, as well as the cross-border areas of Ethiopia and South Sudan, and also northwestern parts of Kenya. And when you look at the analog years based on the sea surface temperature over the tropical ocean, and as well as based on the evolution of the El Nino Southern Oscillation Index, we found that 2021 and 2017 are the years that have strong correlation with the current SST pattern. So when you look at the SST anomalies, the current one is the top one, and the 2021 is the next one. And you can see that this cooling over the eastern part of the Pacific Ocean and also warming over the western part of the Pacific Ocean. And Dr. Stefan indicated that that part of the Pacific Ocean is very important for this March to May rainfall season. And also currently we are in transition from the La Nina phase, which is the map that you see on the bottom left. So we are moving from this La Nina phase to El Nino phase. And when you compare that evolution with the past years, we found that 2017 has a strong relationship. And when you look at the rainfall patterns for the 2 years, again, they are showing below average rainfall. We also produced other indicators, including this probability of exceedance. Then when you compare again the probability of exceedance for 200, 300, and 400 millimeter, again, we are expecting lower probabilities compared to the climatology period, particularly over these parts of the Somalia, southern Ethiopia, and as well as the eastern Kenya region. We are saying this rate, that means the probabilities are lower, exceeding for 300 and 400 millimeter for this region. We also looked at the standardized precipitation index based on the observation and as well as the forecast. And again, the results shows that there's a long-term deficit and widespread drought over most parts of the region, particularly on the 9 months SPI and the 15 months SPI. This is one of the drought indicators that we use. So what it tells us is, even if it rains, because of this, the failed rainfall season in the past, again, it requires a long time to recover. And looking at the onset, presented the expected onset dates on the left and the probabilities for delayed, early, and normal onsets on the right. Again, we are expecting a delayed onset over the northeastern parts of Tanzania, parts of Rwanda and Burundi, and as well as a few areas of southern Somalia. An early onset is expected over the southwestern parts of South Sudan. And when you look at the expected onset dates, we are expecting onset in much of this southern parts of Kenya from the end of March, in southern Ethiopia and Somalia from the first week of April. We also looked at the length of dry spells after the onset, and we are expecting longer dry spells over most parts of Tanzania, Kenya, parts of Rwanda and Burundi. And this dry spells, the length after the onset is from 8 to 9 days, but this will not be the only maximum dry spell, but we have other dry spells also within the season that occur. And this, when you look at the time of this dry spells on the right, you can see that from the 15th of April over parts of Kenya. When you look at the temperature forecast, again, it was showed by Dr. Zaudu, we are expecting warmer than average over most parts of the region, and the enhanced probabilities are indicated over northern part of the region. In summary, we are expecting depressed rainfall over eastern parts of the region, mostly over Somalia, southern Ethiopia, Kenya, and also western parts of Uganda and South Sudan. A delayed onset is predicted over the northeastern Tanzania and also Rwanda and Burundi. And an early onset is expected over southwestern parts of South Sudan. And temperature is expected to be warmer than average over most parts of the region. Thank you.
Thank you, Dr. Sen, for adding those insights from the previous day's presentation and linking it also with the global. So now the next series of presentations will be from the sectors, reporting on the key implications and management strategies for MAM 2023 season. So the first presenter will be from the agriculture and food security, followed by disaster risk management. Please prepare the display accordingly. Thank you.
Okay, good morning. My name is Ahmed Suleiman. I'm from ICPAC, and I will be going through the food, agriculture and the food security sector impacts and advisories on MAM. So, as you have heard from the first, my brother, the region have been experiencing 5 consecutive failed rainy